think we should take a look at that with my special slow motion camera. Slow motion means that we can see things that happen really quickly, much slower. So let's use it and see what it looks like when I blow air through the bubble mixture in the wand. Here goes.
Wow! Look how the bubble mixture stretches and then breaks off into a wobbly, round bubble.
Do you know what that round shape's called? That's right, it's called a sphere. Look at that lovely sphere-shaped bubble. But do you know how soap and water make bubbles and why bubbles are a round shape? To find out, I think we need to take an even closer look.
When we blow a bubble using bubble mixture, it makes a round shape made of bubble film. The bubble film has 3 layers. A thin layer of water sandwiched between 2 layers of soap. Inside the soap layers are millions of soap molecules. Each soap molecule has 2 parts, a head that likes water and a tail that doesn't like water. The heads of the soap molecules push towards the water, while the tails pull away from the water. The pulling and pushing makes the mixture stretchy enough to blow bubbles with. So when we blow air through the bubble wand, the mixture stretches out. At first it's wobbly, but because the soap molecules are pushing and pulling in every direction, the bubble quickly makes the tightest shape it can around the air inside, making a sphere-shaped bubble.
Bubbles are so interesting, aren't they? They're made because of the way water and soap work when they're put together. But to help us understand this, we need to know that water has something called surface tension. Can you see the top of the water just here? It almost looks like it's got a kind of skin on the top, doesn't it? And that's because every droplet of water is made up of millions of tiny water molecules. And those water molecules like to cling together really tightly. And it's because of the way they cling together that makes that skin. And that's what we call surface tension. I can show you surface tension if I use a paper clip just here. Paper clips are made of metal, so they're heavy. So you might think that a paperclip would sink if we put it in water. But can you see? The paperclip is floating. And that's because of all those water molecules that are clinging together really tightly, making surface tension, which is stopping the paperclip from sinking to the bottom. Now watch what happens when I put a little bit of soap onto the top of the water. Did you see the paperclip sink to the bottom? That's because of the way soap and water act when they're mixed together. All of those soap molecules work really hard to pull the water molecules apart, and that makes the mixture more stretchy. Stretchy enough for the paperclip to sink to the bottom.
But how does surface tension affect bubbles in the air?
Can you see that the bubbles pop as soon as I try to touch them? That's because when we touch a bubble with our dry hand, we break the bubble's surface tension. Our hands have a little bit of oil in them and that keeps them nice and soft, but soap loves oil. That's why we use it to clean dirty, oily dishes. So when a soap bubble lands on our oily hands, those soap molecules try to take the oil away, but this bursts the bubble. So what can I use to try and help me catch a bubble without it bursting? I'm going to use a glove. Now let's see what happens. Whoa! The glove is stopping the soapy bubble mixing with the oil on my hands, which means I can catch the bubble and even bounce it. Wow! I loved finding out how bubbles work. Did you? What was your favourite part?
Can you remember what it was that stopped the paperclip from sinking in the water? That's right, surface tension. Did you hear the sound the bubble machine made? Did you see the bubbles being blown in slow motion on my special camera?
Safely. That's right, it was wrapped in this. A lot of mushrooms. Unlike plants, mushrooms don't grow from seeds like this. Instead, they grow from something called a spore, but spores are so tiny we can't see them. They're microscopic. And to see microscopic things, you need a very special microscopic camera.
This helps us see things 1,000 times bigger than they actually are. So let's see if we can see the microscopic spores on this glass slide.
Wow, can you see that? All of those tiny little dark ovals, those are the spores. And every single one of those will grow into a mushroom. The first thing we need to make a spore into a mushroom is compost, and it gets delivered here in this big lorry. And look, there it is, going up that conveyor belt now.
It's really noisy, isn't it? We can use compost to grow lots of things, like plants, flowers and vegetables in the garden. This compost is made of straw, water and a powder called gypsum. And it's a bit smelly. That's because the last important ingredient is poo from farm animals like chickens.
This machine spreads a layer of compost onto a mat, and then a layer of a type of soil called peat is added on top before it all gets a sprinkling of water.
The spores have already been mixed into this compost, and because they have grown a little, they're now called spawn. They're moved inside to grow some more on these long factory shelves.
They're a bit like bunk beds, but for mushrooms.
To help the spawn grow, everything inside the room is controlled by a computer. The temperature, the amount of air, even the water.
The computer controls an automatic watering system, which sprinkles water through here to keep the soil nice and moist. It takes just 17 days to grow a mushroom of this size. But how do we go from the spawn in the compost mixture to this?
Let's see what happens at the different stages of growing.
The spawn has been left to grow on these shelves for 7 days, and it's turned into something called mycelium. And can you see all of this white cobweb-like stuff on top of the soil? Well, that's the mycelium, these tiny white threads. And now the computer will tell this room to get really, really cold. And that cold temperature will make the mycelium clump together and turn into mushrooms. In just 2 days' time, tiny mushrooms start to pop up, and look at all of these. I think they look a bit like little snowmen, don't you? But these aren't quite big enough yet.
Once the mushrooms have popped out of the compost, they grow twice as big every day until they're finally ready.
The mushrooms in here have been growing for 17 days, and that means they're ready for picking, and I've been given special permission to help.
You should never pick mushrooms you find yourself. These mushrooms are grown especially to eat.
Now, today we're looking for mushrooms that are about that size. We call them button mushrooms. To pick them, all I need to do is give the mushroom a twist. I need to just give it a quick trim so it looks nice and clean, and pop it in this container, which is called a punnet.
Once the punnet is full, it's stacked onto a tray and then taken to a really cold room called the cold store, which keeps the mushrooms fresh.
When the mushrooms have cooled down, they go next door, into the packing room.
Here the mushrooms are taken out of the trays and are put onto a conveyor belt.
The punnets are weighed to make sure they have the right amount in, and then they go through this machine here, which wraps them in plastic, ready to keep them fresh on their journey to the shops. Finding out how mushrooms are made here has been so interesting. What was your favourite part?
Do you remember the name of the tiny strands that grow into mushrooms? That's right, they're called mycelium. Did you hear the sound of the conveyor as it carried the compost along? And did you see the tiny mushroom spores under my special microscopic camera?
Safely. That's right, it was wrapped in this.
It'll be mixed with another harder type of clay called shale.
It looks like big rocks, but actually it just crumbles away.
The shale and clay mix is taken by a digger to the plant pot factory, where it's ground down into a fine powder in this crushing machine.
The crushed up clay then travels along conveyor belts. Up here, over there, down here, and it ends up here. When the clay powder is ready to be used, it travels to this machine. It's called an extruder.
This mixes the powder with water to create a solid clay.
Look, can you see how the mixture is being pushed out of the pipe and then a wire comes down and plop, it falls onto the conveyor belt. And this is called a slug. Look at all these slugs. It's a funny name, isn't it? And each slug is enough to make one plant pot.
The slugs travel onto a robotic machine called a pot press. Here they're sprayed with an oil to stop them from sticking as they slide down into a plant pot mould.
The moulds are spinning round really fast to make sure that the clay is spread evenly. The top part of the machine then presses down on the clay, which makes it squidge up around the sides to make the shape of a plant pot. Look, can you see it? There it is. Lastly, a robotic arm gently picks up the plant pot and puts it on a conveyor belt. And here it comes. But these ones are still slippy and wet. You can't put plants in a pot like this. So first, they have to be dried.
The pots and some pipes, which are also made from clay, are put into a special dryer for 13 hours. Then, to make them even harder and even stronger, the pots need to get very, very hot in something called a kiln.
Wow, this is the kiln and it's extremely hot.
The tunnel inside gets heated to over 1,000 degrees, so I'm making sure I stand well back.
To show you just how hot it is inside, I've got my special camera with me. This is a thermal imaging camera and it shows us how hot or cold things are by showing different colours. Cool things tend to look blue, but hot things look yellow, and really, really hot things look white. What colour do you think it's going to be inside the kiln? Everything is bright white. Wow.
The pots take 6 hours to travel slowly through the kiln.
And here they come out the other end. And look, the heat has made them change to a lovely orange colour. The final thing to happen is that once they've cooled down, they come here for inspection. If a pot has a crack in it, it will make a really dull sound. But this one is smooth and solid. So what sound do you think it will make? This one sounds like a bell, and that means that it's ready to go. I think it's perfect for some plants, don't you? I loved seeing how plant pots were made. What was your favourite bit?
Do you remember what the lumps of clay were called that are used to make each pot? They're called slugs. And did you hear the sound the solid pot made when it was finally ready? Did you see my special camera when we looked inside the kiln? It was so hot, it turned white.
So the next time you see a plant pot or you have a go at planting some flowers yourself, you'll know how it was made. And now you know how swings and slides at a playground work. Right, it's time I finish planting these flowers. See you next time.
There are lots of things all around us, exciting things that
Safely. That's right, it was wrapped in this. Being underwater. But remember, this is a special waterproof camera, so you mustn't try this with your camera at home. Okay, ready?
This is a big fish tank they have at the aquatic centre to keep lots of fish in before they are sold. Can you see them swimming about?
I love watching the way their mouths move. Can you see that? They go pop, pop, pop.
But if we want to keep fish at home, we need a much smaller tank. Shall we see if we can find one?
At the bottom of a fish tank, you might put a layer of little stones called gravel, or perhaps some water plants. But do you know what this is? This black plastic box. It's called a filter, and it helps to keep the water inside the fish tank clean. But do you know how a filter works? I think we need to take a closer look.
When we keep fish in a fish tank, we feed them fish food. This gives them energy to grow and swim around. When the fish have eaten and used the food as energy, they poo out the waste into the water. Fish also let out waste through their gills. This is how a fish goes for a wee. Fish wee has a chemical inside called ammonia that can be harmful to fish if it's left in the tank for too long. The filter removes the poo and ammonia from the water. Inside is a pump and a sponge filter. When the pump is switched on, it sucks in the water from the tank. The filter has lots and lots of tiny organisms inside called bacteria. As the water is pushed through the sponge filter, the bacteria turn the ammonia into a chemical called nitrate, which is less harmful to fish. And any bits of poo get caught in the sponge filter. So the fish have nice, clean, filtered water to swim around in.
That is so clever, isn't it? I've got a special underwater microphone with me. It's called a hydrophone, and the hydrophone will let us hear what it sounds like underwater. But remember, this is a special microphone, so you mustn't try this at home. Let's give it a go. Wow, can you hear that? If I take the hydrophone out, we can't hear anything. If I put it back in, I can. That's the sound of the filter working. Actually, if I move the filter up a little bit, oh, can you see it making bubbles on the surface of the water? Because waste builds up in the filter every couple of weeks, it needs to be cleaned out. And I happen to know one that needs cleaning today. I've been given special permission to clean this one. And the first thing we have to do is switch the filter off. Now I'm going to carefully lift it out of the water so that we don't disturb our little fish friend. Now, if I take the top of the filter off and have a look inside, we can see this part here. It looks a bit like a propeller, doesn't it? And that's what spins round and round and round to suck the water into the filter. Now, if we take a look at the other end, we have this spongy part. This is the sponge that traps all the bits of dirt and waste. And to clean this, I'm going to rinse it in some water from the fish tank. Let's give that a good rinse. A bit of a squeeze. Oh, look at all of those bits of dirt coming off. That's the poo and the plant and bits of old fish food. There we go. The sponge is much cleaner, but look how dirty the water is. But now we can see all of the tiny holes in the sponge. And that's where the helpful bacteria live that turn the ammonia into nitrate. All that's left to do is pop this back into the filter. Now I put this back into the fish tank, and there it goes.
Ready to keep the water clean for the fish.
Just need to wash my hands. I loved seeing how fish tanks work. What was your favourite part?
Do you remember what the part of the filter is called that traps the fish poo? That's right, it's called the sponge. Did you hear the sound the filter made while it pumped the water? And did you see all the fish swimming around on my special underwater camera?
Safely. That's right, it was wrapped in this. At the top of every wind turbine, there are 3 giant propeller blades. 1, 2, 3. They look like the propeller blades you might see on a plane, don't they? And they make a great swishing sound as they swish through the air.
The blades have a special curved shape, which helps the wind move the blades round and round.
Now, if you look closely at the middle, the part where all the blades are attached, can you see that circle shape? It's called the spinner because it spins around when the blades move. And the spinner is attached to the main body part called the nacelle.
The nacelle can turn so that the blades are always facing the way the wind is blowing. Let me show you with this little windmill.
When I face the windmill in the direction of the wind, it spins really fast. But when I turn it away from the wind, it stops. If I turn it to face the wind again, look, there it goes. That's because the wind is catching the blades and that's making them turn around. And exactly the same thing is happening all the way up there. But how do the wind turbines make electricity from the wind? To find out, I think we need to take a closer look.
At the top of the wind turbine is something called a yaw system. The yaw system tells the blades which direction to face to catch the most wind. As the wind blows, the blades turn around. The blades are connected to big rings of magnets. And as the blades turn, they turn the rings of magnets around coils of copper wire. The turning makes energy in the copper wire, and this energy is called an electric current or electricity, and this is measured in volts. The stronger the electricity is, the more volts it has. The electricity travels through cables inside the tower to a machine called a transformer. It changes the weaker volts of electricity to stronger volts so that it can go further. The electricity travels to 2 different substations, which make it even stronger. Then it's sent along cables on pylons and delivered to our houses for us to use.
How clever is that? We can make electricity from wind. I wonder what it looks like from all the way at the top of a wind turbine. Shall we find out? Andrew is a service technician, and Andrew's specially trained to go all the way to the top. Now, I'm going to give Andrew one of my special cameras, and I've also put one on his hard hat, and then we can watch everything that's going on inside the wind turbine on this screen just here. Andrew, over to you. This is so exciting.
Before Andrew can go up, the turbine has to be turned off.
From the ground to the top of the turbine, it's 90 metres.
That's almost as tall as Big Ben.
Wow! The tower is so tall, Andrew has to go up in a lift. There he goes, and it's a long way up. It will take about 5 minutes for Andrew to get to the top. It is so high up there. Oh, I think Andrew's reached the top. Did you see that? Oh, Andrew's waving. Wow! And can you see all of those wind turbines in the distance? We can see for miles and miles, can't we?
Now Andrew is safely clipping his harness so that he can look at the blades.
And they're 55 metres long. The view up there is absolutely incredible. What an amazing job Andrew has.
Now Andrew's back inside. Look, there's the generator. It has the magnets and copper wires inside that make the electricity.
The electricity travels underground through the cables and it arrives here at the substation. And this is where the electricity from all of the wind turbines is collected.
It's then sent through overhead cables attached to these huge metal towers, called pylons.
Can you see the cables? The pylons go for hundreds and hundreds of miles all over the country, delivering electricity to our homes, buildings and shops, ready for us to use. I loved seeing how electricity is made from the wind. What was your favourite bit?
Do you remember what the part is called that the blades are attached to? That's right, it's the spinner. Did you hear the sound the wind turbines made? And did you see how high Andrew was when he reached the top of the turbine?
Safely. That's right, it was wrapped in this